Okay, today we are going to study about electroplating. So first of all, we have to consider what are the uses of electroplating. Electroplating is used to coat the jewelry with gold and silver, then to coat the ornamental objects, trays, door looks like different objects to add them worth looking by covering with or coating with shiny metals. So then we have to consider what are the metals that is used for the electroplating. So basically those metals could be tin, copper, silver, chromium like metals. Okay, then we have to think of what are the special properties of different metals that we are using for the electroplating. So the very first criteria is, so the particular metal that we are used for the electroplating has to be resistance for the rusting. So that is very important, resistance for the rusting. That means it could not get rusted or react with oxygen and water. Then the next case is attractive color. Since most of the things basically made out of iron like metals, so which does not having much of attractive color, therefore we have to give it a worth looking. That is why copper color, silver color, likewise attractive colors are used for the electroplating. Then the chemical inertness, this is very important. In the basic in the normal environment, what we could find water, we could find oxygen, then salts, then acids like different chemical substances we will be able to find in the general environment. Therefore this particular metal that we are used for the electroplating should not react with those chemical substances available in the general environment. So if it's going to react with water, oxygen, acids, bases, or any other basic chemicals, so that could be a problem and there is no value of doing electroplating. Then the important thing is how we are going to make a electroplating system. Here you can see a spoon which is made out of iron, and then it is going to coated with the copper. So for that thing we are using a copper plate, and so the electrolyte solution as copper sulfate. So the very important thing that we have to consider, we have to always take the whatever the metal object that we wanted to get coated as the cathode, because in the cathode, so the reduction is happening over there. So you can see here the copper 2 plus ions from this electrolyte get 2 electrons and become copper solid. That copper solid is going to plated on the this particular iron spoon and it get covered with the copper. Therefore, to make the copper atoms from copper 2 plus ions, so there should be reduction process, or should be taking electrons by the ions, and it could produce the metal atoms. So for that thing we have to take whatever the metal object that we want to plate as the cathode. Then the next thing is about the electrolyte solution. Actually, for the electrolyte solution, we have to use a salt of particular metal. As example, if you want to do the copper plating, so we have to use copper sulfate as the electrolyte. If you are using salt of any other metal, so that metal also could be get reduced over here and get coated. Therefore, we have to use the salt of the same metal that we are going to plated on the cathode. Then as the anode, we should have to use a stripe or a rod of particular metal. As you can see here, there is a copper plate as the anode where there is oxidation happening. With the oxidation, the copper atoms over here get into this particular electrolyte solution as copper 2 plus ion. So this should be the copper 2 plus ion supplier to this electrolyte solution, and from the electrolyte solution the copper 2 plus ions will be taken for the reduction process, and those copper 2 plus ions become copper atoms and coated on the cathode. Okay, then we have to consider many important things when we are doing high quality or smooth electroplating. First of all, we have to use the electrolyte electrolyte with a low concentration. Then the concentration of the electrolyte should be low. Otherwise, a huge amount of particular ion could be coated on the cathode. Therefore, to prevent that thing, so to have a smooth coating of that particular metal that we are going to electroplate, so the concentration of electrolyte should be lower. Then the other thing is the current used for the plating also should be smaller DC current. Otherwise, there could be overcoating, or there could be non-smooth coating over there on the cathode. That could happen because if you are putting huge current, that could cause to higher the reduction speed. Therefore, a lot of metal ions could be a huge amount of metal ions could be suddenly coated on the cathode, which could not allow to have smooth coating. Then the next thing is slow mixing of electrolyte solution. We have to do it because the thing is, you can see here the particular ion in the electrolyte get continuously coated on the whatever the object that we are using as the cathode, and then the ions will be released to the electrolyte with the oxidation process. Therefore, if you are not properly mixing this particular electrolyte solution, what happen? So in different parts, that means it closer to the anode and closer to the cathode, there could be concentration variation in this particular electrolyte. Therefore, to make a homogeneous concentration of particular ion that we want to get coated, so we have to slowly mix this electrolyte as well. Then the next thing, here we are using the silver plating onto the iron spoon. So iron spoon is used as the cathode over here, and there is silver rod that we are using as the anode here. Then with the oxidation, you can see that the silver atoms get oxidized and it releases the electrons while it get into the electrolyte solution. You can see here the silver 2 plus ions get into the electrolyte. Then in the cathode, what happened? The silver 2 plus ions in the electrolyte solution get reduced. That means it's taking electrons, and the silver will be deposited on the iron spoon and it gets coated with the silver. Okay, then many important things we have to consider. So you can see with the addition of silver 2 plus ion or the oxidation of silver atoms into silver 2 plus ions, what happened? The anode get, or the silver rod get dissolved over here, and the silver get deposited on the iron spoon with the reduction reaction. Then next we can consider over here, so we have used silver nitrate as the electrolyte here. Therefore, we could find silver ions as well as nitrate ion on this particular electrolyte. Here, this is as this is a aqueous solution, so there is partial ionization of the water. With that partial ionization of the water, there could be OH minus ions as well as there could be hydrogen plus ions. Then the negative ions in this particular electrolyte could get attracted towards the anode. But the problem over here is, so we have to think of the oxidation ability of these particular negative ions as well as the silver atom. When we are comparing the oxidation ability of these three components, so silver atoms in the silver rod as well as the nitrate and hydroxide ions from the electrolyte, so we are able to find the oxidation ability of the silver atoms are higher than the oxidation ability of the nitrate and hydroxide ions. Therefore, the silver atoms from the silver rod get oxidized and it could release the electrons while the silver 2 plus ions are released to the electrolyte. Then the next problem, as we have discussed earlier, so right now we all know there could be hydrogen plus ions which release to the electrolyte by the partial ionization of the water. Then rather than the silver 2 plus ions, these H plus ions also could get attracted towards the cathode. That could also happen. But when we are considering the reducing ability of H plus ions as well as the reducing ability of the silver 2 plus ions, so for this thing we are able to use the activity series as well. From the activity series we are able to find out that the reducing ability of the silver is higher than the reducing ability of the hydrogen plus ions. Therefore, the silver 2 plus ions get electrons and it gets reduced as silver atoms, so which happen in the cathode